A groundbreaking new theory has emerged, sending shockwaves through the scientific community. Could it be that even before the Big Bang, a mysterious form of dark matter lurked within the universe? For decades, the Big Bang theory has stood as the cornerstone of cosmology, widely regarded as the origin of time, space, and all known matter, a seemingly immutable starting point. But consider this: if something already existed before the cosmic drama began, it would shatter our entire understanding of the universe. Recently, a team of top scholars from the University of Texas at Austin introduced a revolutionary model. Their research suggests that dark matter, which makes up 27% of the universe yet remains elusive, may not have originated after the Big Bang. Instead, it could have taken shape during a pre-Big Bang phase, challenging the very foundation of our cosmic narrative. This theory, known as warm inflation driven by the ultraviolet freeze-in mechanism, or the Wi-Fi model for short, has the potential to completely reshape our understanding of the universe's birth sequence. In the upcoming video, we will delve deep into this new theory, exploring how it challenges traditional cosmological beliefs and examining the profound impact it could have on the future of physics and our comprehension of time itself. According to the Wi-Fi model, dark matter did not gradually form after the Big Bang, as previously thought. Instead, it was born during an earlier period, the rapid inflation that occurred almost immediately after the universe's inception. Unlike the conventional view, where everything was thought to have been diluted during inflation, the Wi-Fi model proposes that the universe retained a persistent hot soup of particles. In this unique scenario of warm inflation, the inflationary field driving the universe's expansion was not isolated. It actively interacted with other particles, creating a high-energy environment. Through a peculiar process called ultraviolet freeze-in, dark matter came into existence. Under this mechanism, dark matter particles accumulated through extremely weak interactions, never fully reaching thermal equilibrium within the particle soup. This allowed them to survive the universe's rapid expansion. In essence, the ultraviolet freeze-in mechanism offers a novel pathway for dark matter production, significantly increasing the yield of dark matter particles compared to traditional inflation models, especially when dealing with complex high-energy physics concepts involving high-dimensional operators. If proven true, this would mean that dark matter, the invisible scaffolding of the universe, predates the Big Bang. This discovery directly challenges the long-held belief that the Big Bang marks the beginning of everything, hinting at a more complex, pre-Big Bang cosmic era. The existence of dark matter before the Big Bang isn't just a matter of chronology. It also opens new doors to understanding its nature. Since dark matter cannot be directly observed through conventional means, uncovering its origin could help us deduce its hidden properties, such as how it interacts with ordinary matter, its mass range, and its lifespan. The Wi-Fi model's dark matter generation mechanism via ultraviolet freeze-in is highly distinctive, emphasizing the extremely weak coupling between dark matter and particles of the standard model. This aligns perfectly with the elusive nature of dark matter that has puzzled scientists for so long. Furthermore, this theory could have far-reaching implications for the formation of large-scale cosmic structures. If dark matter was already in place before the Big Bang, it may have played a decisive role in shaping the distribution of matter, the formation of galaxy clusters, and ultimately, the grand cosmic structures we observe through telescopes today. In other words, the early emergence of dark matter compels us to rethink the history of the universe. It's no longer a simple, linear beginning but rather a complex, potentially multi-layered historical process. The implications of the Wi-Fi model extend far beyond the realms of particle physics and cosmology. It may force us to completely reimagine the reality before the Big Bang, a primordial domain governed by different physical laws, with its own timeline and structure. This theory has, in essence, opened a door, offering us a glimpse of a fundamental possibility. Before the Big Bang, the universe may not have been a void but a rich and complete cosmic saga. Under the Wi-Fi framework, the inflationary field is no longer an isolated, impersonal entity. Instead, it is deeply immersed in a seething ocean of particles, constantly exchanging energy and momentum with them. This interaction reveals that long before the familiar fabric of space-time took shape, there existed a complex, dynamic system full of rules and interactions. This naturally raises an exciting question. Does this support the theory of a multiverse or, more ambitiously, the cyclic universe model? If inflation didn't erase everything as traditionally believed, but instead preserved and even gave rise to precursors like dark matter, then it's highly likely that the universe isn't a one-time creation but an ongoing, evolving process. Theories such as eternal inflation already propose that our universe might be just one bubble in an infinite sea of bubbles, each with its own physical constants and many Big Bangs. The possibility of dark matter forming or surviving during inflation implies a cosmic continuity, linking countless cycles of birth, death, and rebirth. From a more philosophical perspective, all this prompts even more profound questions. If entities existed before the Big Bang, then where is the true starting point of time? According to standard cosmology, time began at the moment of the Big Bang. But if dark matter emerged much earlier, then time didn't start anew, it was a continuation or reconfiguration. This means that cause and effect relationships were at play long before our perceived starting point of time. The pre-Big Bang timeline may have already quietly determined the fate of the subsequent universe. This not only shakes the very foundation of physics, but also challenges our understanding of existence itself. If the Big Bang isn't the beginning of everything, then our current universe is merely a chapter in a much larger, older narrative, governed by deep-seated laws yet to be uncovered. The next obvious question is there a way to actually detect or verify the universe before the Big Bang? Perhaps the answers lie hidden in the subtle patterns of the cosmic microwave background radiation or inscribed in the unique spatial distribution of dark matter. While these questions remain unanswered for now, the Wi-Fi model has given them a solid physical basis for the first time. No longer are they just theoretical speculations, as the model anchors these grand ideas in the observable properties of dark matter through the specific ultraviolet freeze-in mechanism. That's why this theory is so exhilarating. It's not just expanding the boundaries of our physics. It's also upending the very foundation of humanity's narrative about the birth of the universe. For the first time, we're seriously considering the possibility that we stand on the brink of a reality far more vast, ancient, and beyond our imagination. Conclusion: if the Big Bang isn't the beginning, then it's just a chapter in a much grander story. If dark matter has always been there, then it's a clue left to us from a previous world. The Wi-Fi model has torn open a tiny crack, allowing us to glimpse the forces that stirred in the primordial darkness. Perhaps there are countless unexploded universes out there, with countless physical laws operating in silence and countless fragments of time drifting where we haven't yet looked. The real question is, are we ready to face this deeper, more mysterious cosmos? Thank you for watching. Please stay tuned for more films on cutting-edge technology.